Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Hey there, and welcome to another episode of the Digital Enterprise Society podcast. Thank you so much for picking this show. There are so many things that you could be doing right now, and yet here we are in your ears, because this show was designed to be the show that is a resource for those who work in and around PLM. The Digital Enterprise Society is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor to co-host this show every single week with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors. Hey, Craig, here we are again.
Yeah, hi, Thom. We've got a repeat guest today, and we're going to chat a bit about one of the things that's maybe quite confusing. It's this machine learning and adaptive stuff that you hear about, and whether it comes up in autonomous vehicles, cars or drones or whatever, or it just comes up in the way a factory adjusts to reality. I think it's important to understand some of the basics and how it affects PLM. And so today we got a repeat guest. The last time we talked with this gentleman, we were all together in San Diego. and gosh darn it, here we are 3 years later, and my goodness, we never predicted that this would happen, right? That we'd all be now virtual for all the time, it seems like. So,
that's right. In fact, our plan was after that conference, we were going to go to more conferences and do more live interviews, because we thought, this was a great way to get a lot of good guests and everything else. And then we were locked down and we weren't able to go to more conferences and record live in person. But the show must go on. And here we are recording over Zoom. And for all of you, this is the second time that Martijn Dullaart has been here on the show. He is a business architect in enterprise configuration management at ASML. And what he does for a living is he helps make processes better. And he does that with a focus on configuration management. And today he is joining us from the Netherlands. Hey, Martijn, welcome back to the show.
Thank you, Thom. And thank you, Greg. It's good to be back.
So for those who may not have heard the first episode or they don't know you, give us a little bit about your background. How did you get into this crazy world of PLM?
It started already during my master thesis, where I did something in the area of product lifecycle management in the automotive industry, and then I got my first job as a consultant implementing PLM systems. And then slowly I moved to a position within Philips, consumer electronics at the time, building a PLM system, customized basically. And after a while, moving more in focusing on configuration management, and also coming into contact with IPX and the CM2 model. And then a little over 5 years ago, I joined ASML as a business architect for enterprise configuration management, where I now do most of my work. And then, of course, in the time I have left, I sometimes write about it.
Well, hi, Martin. That's great. And that's what we're going to talk about. You and I have a bit of a history. Our two companies, along with a few other companies, decided to work with IPX and assess how well the Siemens tools, and I don't know if you guys did it for any others, but how well Teamcenter supported the notions in CM2 and the capabilities. And so we did that together, and we published some results. And then we got to do that interview, it was 2.5 years ago, almost 3 years ago in the summer. And then I can't believe, like I tell Thom all the time, I can't believe this past 2.5 years has gone so fast. So I was pleased when I realized you were going to be a repeat guest, and I was reading your series of articles on the future of configuration management. And I think it's really important for our listeners to understand how to put in context, if you will, all this stuff about adaptability and machine learning and the impact it has on really products, right? And so let's chat for a bit about that. Now, I remember with IPX and you guys, you did some really good definitions around different kinds of models. And I think I want to start with that just to get everybody on the same page. So what's important? I mean, a model is a model, right? A model lets you validate a product, or are there other models that people should be aware of and think about?
I think there are a lot of people think about, when you talk about a model, that we often talk about a 3D model, because that's probably the first model a lot of people think about. It's also probably one of the most visualizable models in that sense. But there are a lot of different types of models. You can also think about a system engineering model, where it's not really a 3D model, but it's more about identifying the functions, the logical components, the physical components, and all the requirements associated with those elements. And that can give you a lot of different insights in how you break up a product, and how the requirements flow down basically from the top of the product all the way to the nitty-gritty components. And in the past decades, so to say, often these type of documentation were not modeled, but were just written down in a Word document.
Right.
And then a large part remained in the heads of the system engineers. But how do you flow down that information efficiently to the engineers that actually have to develop the product and make that 3D model of a part, right? And I think that's with the model capabilities of today, we are basically bridging all those gaps. All those expert domains basically are creating bridges between one another. But it also creates challenges, because how do we efficiently communicate this information? Even though it's modeled, we still have to think about that. And how do we manage change on all those models in a way that is efficient and fast, but also ensures the integrity of all that configuration information that flows throughout a supply chain, basically.
Yeah, so a couple of points I want to add. So people think about a virtual mock-up because we can visualize it, right? But it's really more powerful if they can also think about it in a fourth dimension, the passage of time, right? I mean, there are interesting things that are in a mechanical design that help manage noise and help manage thermodynamics. And you would never realize that if you didn't think about the passage of time. And of course, with the passage of time comes the changing of forces that affect your system. So I think this notion of model, maybe that's part of the problem, is we have a notion of a single model, the 3D mock-up, and that's good for fit and form. But anybody who's done engineering for a long time knows that you got to do fit, form, and function. And function is a form of behavior, right? How does the system behave under whatever circumstances you put it? And so configuration management helps by saying, well, this is the conditions, right? The environment and also the state of the design that we're evaluating as we go through this environment. Okay, well that's great, but the trouble is we never know all the story, right? We put our systems, automobiles in my career, into conditions that we didn't plan on, and so now there's a new discovery. And I think one of the things I like about your sequence of recent articles is you're talking about, well, that's a new intention, right? And I'm like, oh, okay, well, does that mean then that the models change? And I'd like you to elaborate on that. And then we'll come back to configuration management, because this sounds impossible to solve then. So what happens when in 4D, when you discover a new load case, a new way your system's being used, and it reveals a failure? What does that do to the baseline of models?
In my perspective, and that you cannot have everything up front. Even though we would love to know everything up front, that's just impossible. So we have to be able to accommodate the fact that things will change, even though we did not foresee that change coming. So if you say, well, we are starting to use a product in a different environment, or the conditions changed, or whatsoever, that caused a problem. that problem basically, in my opinion, leads to, in the end, a change request. If you know what the root cause of that problem is, you did your analysis, you figured out what the problem is, then you basically say, well, we have to apply a change request to ensure that this product can also operate in these conditions. Mm-hmm. A change request needs an analysis. What is the impact of that change? And that's where the word intention comes in. That's where you basically start modeling the intentions of the change that you want to achieve. Some people also call it the proposal, but the intention captures in a model speak, so to say, what you are going to impact. And based on that, based on the set of intentions, you can then also distill what will it cost me, right? Because there's always a cost involved. What are the risks that are involved? And then come up with a business case that can either be approved or rejected, because in the end, it doesn't mean that every change gets approved.
Yeah, I like the fact that you brought up risks, because I think that's the aha, at least for all of us that are in some form of product that we sell to somebody else and they use it. Whether you're talking about airbags that go off at the wrong time, and then when you really dig into that, it was this notion of a different intention, though it ended up being a manufacturing flaw. But it didn't fail everywhere. It didn't fail in the northern hemisphere. It only failed in the tropics, which is an interesting condition, right? Why was that? Well, it turned out it was related to humidity and other chemistry inside the propellant. So my point is the configuration was misunderstood. It wasn't broad enough, or the risk wasn't characterized properly. And so I think this notion of a model helping you understand intention, the model also has to know its limits, right? And I guess that's a configuration. I mean, is that the point here?
In a sense, basically, if you talk about different models, one of the models that we identified also with IPX was the application model.
Okay.
What are the application requirements of the system that we're trying to deliver? Within the context of application requirements is also the applicability of that system, right? Where can I apply the system? What are the conditions that we can use the system in? If the conditions say a certain humidity and we apply the system outside of those parameters, that could cause a problem, right? If we have set those parameters correctly and it then fails, then somewhere down the design phase, something went wrong because we didn't test it properly or whatever, and then we have to fix that. But if you already did not identify the conditions already early on in the application model, of course, you will not create a product that will be applicable to be used in those conditions.
Yeah, and I picked on an automotive example, the airbag failure a few years ago. All failures we study and we figure out, especially if they're large safety or cost impact, and then we figure out a solution. And sometimes it's a Band-Aid. It's an intermediate solution so the product that's currently in the field can continue to operate, right? So we got these different models. I understand that. One of the problems we're dancing around here is that we didn't know enough when we designed the product. One of the interesting things with artificial intelligence is now we have a notion of computers sensing, pattern matching, reaching a conclusion, and maybe even adjusting the way they operate. Now, we've done this for a long time in really simple ideas on friction management in an engine or a transmission, and then we adjust pressures of the oil lube circuit and so on. You probably have examples in your business too, but the affordability of machine learning and then its explosion across industries, what happened to the configuration? I mean, we're learning something new all the time, and I would guess these application models and even definition models need to adjust based on the machine learning. But then it seems to me that just blows up the configuration.
Yes, there are significant challenges, and I think we just started to understand what's going on in this domain. If you look at machine learning, and even in the complex situations where machine learning, you have the source of the machine learning is it could be a multitude where you have a kind of federated approach where then the data is collected and then a conclusion is created, and that's then sent to every node of where machine learning is being applied, and that goes on. Then you have all kinds of different situations. First of all, what of the part of the configuration information has changed? You need to know that. Secondly, what about all kinds of regulations you have to deal with? to what degree did that information exchange fall under export control?
Okay.
It's very unclear at the moment. It's very unclear. I'm not an export control expert, but I know people in this domain are struggling with this because information is also export control rules are also applicable to information exchange. So to what degree can we just exchange this kind of information without problems?
Well, that's complicated and well beyond our podcast. I think
it is. It creates a lot of complexity, and even if you dumb it down to a very simple example, and this is not even machine learning, this is just a software over-the-air update, but it starts with that already. Recently, a German manufacturer of kitchen appliances sent out a software update for its microwave oven combination for a specific one. But in the update, it sent the wrong update. So now the microwave oven combination thinks it's a steam oven.
Oh, great. But it doesn't have the right equipment to run. It doesn't have the right
equipment to work, right?
Yeah. If you did that in the car business, you guys would just fire us. I mean...
And over the last more than 2 weeks already, 2.5 weeks, the company has tried to fix it with another over-the-air update.
Of course.
But the previous update also broke the Wi-Fi connection. So now they have to send in field engineers to actually physically repair the problem. This was just by typing the wrong product number when distributing the information. And it's just a silly mistake that has a ripple effect in the amount of cost and unhappy customers, of course, that you create, because these customers can't use their microwave oven as long as it's not been updated with the proper firmware.
Well, does it even work as a steam oven? Oh, no, it doesn't have the right hardware.
No, it doesn't.
Yeah, okay. Oh, darn. Well, then it's just an
so it's already started just software over-the-air updates that are difficult, right? That whole process to sending the right software with the right parameters to the right products, that's already a nightmare. And these are even relatively simple products. Let's forget about cars. These are relatively simple products.
Yeah, the whole idea of configuration management was with over-the-air updates is, or if you will, updates when it's in the hands of the consumer, right? I mean, that's what we mean. We just use it for the wireless technology. Yeah, car guys have been doing that, and cell phone companies have been doing that for a long time, right? And they've gotten pretty good at this, and they get pretty good at having shadow memories so you can't destroy the old configuration until you're very sure the new one's operating, right? And then they switch over. But I think this is a good discussion about, both configurations matter. The configuration before you do the update and the configuration after the update, not the installation, but the installation and booting so that it's operating on the new one. And then you confirm it, right? There's got to be a verification actually done in the product that whether you're doing checksums on memory or whatever it is you do. So sometimes you just do a control loop, right? Like open up the valve, shut the valve. Did that work like we expected? Okay, if we did, then we're okay and we go. So cars at assembly have an end-of-line test, right? Your products, I'm sure, you build all these wonderful chips for people, or you help build the wafers. You're doing an end-of-line test after an upgrade before you even think about putting it back in the hands of the customer, right? So this is interesting. So do you think all configurations are discoverable then? I have this notion in my head that the configurations used to be bomb-like, right? You had a long list of things and you managed the list of things and you informed the affected people and they had a chance to object if it was going to impact in a big way. Now that you're dynamic, even more dynamic with machine learning, I'm not so sure you have a configuration you review and approve. You might have a configuration you just say, oh, that's what they got, right? Meaning it's discoverable, and then you react to the discovery. What do you think? What's going to happen with configuration?
For a certain part, that's possible, right? Especially if you look at the software being applied on a specific device, understanding the configuration of that device, and setting the right parameters for the software to operate within the right parameters, right? So, I mean, you could turn on or off a switch in the software that allows you to work with a certain hardware. But if the hardware is not there, then of course it will not work, and you must be able to recognize that. That kind of configurability, I would expect to work, and it is possible to work. But I think from another aspect, I mean, if you build hardware, the hardware is there or it isn't.
Mm-hmm.
So you need to know what you are going to build and what you are planning to build. You have to source the materials. You have to plan for it. It's not like software. I can write the code, hit build, and I can repeat that action, and it doesn't take any time, right?
Yeah. Bravo. This is something people don't get. I'm glad you brought this up. The business of building hardware involves capital investment, meaning raw material, moving it around and getting it to the right place.
And a lot of throughput time.
Well, yeah. And the software's different in this regard. The capital investment is the brain in your head that's putting together the new configuration. And you're right, the operation of manufacturing software, if I could say it that way, the build operation, it's almost automatic. It's almost free. And that's a problem from an engineering discipline point of view, because in the mechanical world, you had time to recover, if you want to think of it this way. Okay, I release my change, and it's going to take 3 months to get through the supply chain and back to the factory before it actually starts mass production. I don't want to change it during then, but I actually have a buffer that I could use, right? You don't have that in software. I mean, the truth is you still got to do the validation, so you have to move things around and do it in a different order. But software guys, it's almost like it's too easy, too fast, too flexible to make changes, and then you just hit the automatic build and off you go. It's almost like we need a different engineering paradigm, a different way to go about validation, if you will.
I think the hardware world can learn from the software and vice versa. I think there are good things in the software world. If you look at the way they can easily branch from their trunk to create new versions or new baselines and start to iterate, etc., and even merge it. It's not always nice and pretty, but there are tools to make it more easy. But if you look at the hardware world in 3D model design, for instance, you see that now also happening with, for instance, Onshape, or where you can literally have that kind of branching mechanism where you can try something out, throw it away, merge it, and play around, which creates a kind of flexibility in your design process, right?
Well, and those guys are building the virtual model and interacting with it virtually, right? And before they actually commit to go buy material and make it
exactly. And then,
yeah.
So in your design process, basically, you create a more flexibility, which in the, let's say, more classical CAD tools, that flexibility is very rigid in that sense. You have one way forward. It's the next iteration or not, right? And that's a little bit, I think, sometimes challenging, where in the software world, you could have different projects starting, and then one goes to the branch, and then another one merges, and you have more options. It's not always easy, because the impact analysis, I think, in the software domain is oftentimes lacking, and also not very well supported, which is, I think, much more supported in the hardware world. So I think both worlds can learn from one another to improve their configuration management skills.
Well, I really like your idea point about upfront, when you're still exploring what your design might want to be. The agile methods make a whole lot more sense, and especially since you can almost turn the mechanical design into that same automatic almost experience that the software guy has, where you can just automatically make a new configuration, and then you can rerun the simulation pile you have.
Yes.
And within a few days, what used to take 3 months can now take 3 days. And you'll know, your new design can handle the load cases or not. Now, the other thing we're getting into with more sensing, which leads to more machine learning, is then we find out new things happen. And we kind of touched on this earlier. In that context, you've been writing a couple articles, and I'm looking at one at the moment about intentions are the desire for new stories. It's like, I want to use my product a new way, but I'm not sure if my representations, my validation suite, if you will, is ready to manage that. Can you expand on when you got a new intention show up? how does that affect stories? And more importantly, how does that affect the configuration?
Maybe I think for the listeners, I have to explain a little bit the context in which I introduced the intention. So I started with describing that if you look at most businesses, a lot of the information is residing in multiple tools. So you have your PLM tool, you have your ERP tool, your requirements management tool, and probably they're not 100% in line. Yeah. If you're lucky, they are, but then still the information is still residing in a lot of different tools. So if you want to see the connections between all those information elements, you have to go from tool to tool to tool. And that's not always efficient. So in my articles, I explain that you need to have a kind of a business view of all those objects and relationship. And I call it the business object graph, in a kind of a graph-like database where you can see everything that is normally in all kinds of different tools.
Well, I think it's excellent that you call it a graph. And for those of you that aren't comfortable with the term graph, we're talking about a mathematical model, a graph, okay? And of course, it's in multiple dimensions, right? And that's kind of what's cool about it is it's not like a two-dimensional piece of paper that's an impact matrix. You mentioned that in one of your papers about that's got all these shortcomings because you can't see some relationships. Whereas a graph that you could explore, and I mean explore like it's a trail in the wilderness. If you can explore the graph, you can see interactions quicker that maybe weren't big impacts originally, or big influences, might be a better word.
The graph
and then all of a sudden they become influences, right?
Yeah. Yeah, the graph tells the story, I think, because with all those nodes and those relationships in the graph, you basically are creating a storyline of your product.
Right.
And the whole idea with being able to create intentions that drive for a new story development, so to say, is that intention can be introduced in that graph to explain what you want to change.
Right.
So how you want to change the story. And I think that's the power of graphs, because it is indeed not single or two-dimensional. It shows every dimension of your product with all the different nodes and aspects and views that you have, basically. And I think that's why it's very powerful. The problem with most PLM tools is it's still very much focused on an engineering-only domain, and at least the way it's implemented in most companies. And from a CM perspective, I need to look at end-to-end. I can't look at only an engineering bill of material. I need to also understand how it will impact the field.
Right. Well, and I think the companies that are stuck in the engineering bomb and the manufacturing bomb, right? Those are the two big ones. I think it has a lot to do with that's the way the finance guys work the company, right? It's where you need the money, right? And so engineers are engineers. They're very talented. They can pretty easily work with each other. When you then tell a finance guy, oh no, my configuration is going to morph like an amoeba, right? It's going to move around based upon changing stories. Well, then they say, stabilize the stories. Well, I'm telling you can't, right? I have a bunch of car examples where you took a car into a new market that didn't have very good roads, and all of a sudden your very reliable truck has fallen apart because it's been rattled in ways you didn't intend. Well, that's a new story. If I'd have just had the graph of relationships of the objects, I could have figured out, oh yeah, that front suspension is going to come apart because it can't handle that kind of load on an impact of some kind of pothole or whatever. Anyways, so where's the configuration in the graph though? Is it the whole graph, or is it a trail, a path through the graph, or is it both?
It depends how you look at it. So if I would say that every item has its own configuration as part of the graph. But if you combine all that information, it will lead to a bigger configuration until you reach a system, right? But you can even go beyond that. So if you really go far with this, you could also model in an associated graph model your facilities and how they interact with your configurations when you build them, for instance, and how you test them in those facilities. And if you really want to take it even further, you can even model how your company operates any process, right? And how that is linking to the configuration and to your facilities. It depends on how far you want to go.
Well, that's interesting. So So we're about used up our time, but I really want you to summarize the future of configuration management given machine learning and discovery after mass production.
I think, and maybe that's a strange word, I think the future of configuration management is exciting. And
okay.
I don't think a lot of
it
people
won't be boring.
associate
That's true.
configuration management with exciting. But because machine learning and the fact that model-based is really starting to get root in development processes, I think the way we have done configuration management really has to change and adapt to these changes. And I think CM is about being able to deal with change. Well, now it's our turn to be able to deal with change in that sense.
Well, yeah, and I bravo. And it won't be capital driven. It might be revenue driven, which is interesting. Right? That's the opposite, right?
Yeah.
And I think that's hard for people to figure out because the models of revenue aren't that good. But I do like the fact that you're taking the time to write a blog, write a series of articles. For those of you that haven't been following the future of CM, look it up. Martin's looks like you're putting out a monthly article.
Yes.
And I like where your head's going. And I do think configurations might become discoverable, but as they influence models, at the end of the day, there was somebody that wrote, probably some professor, that said, all models are bad, but some are useful. And I think configuration management helps you make sure your models remain useful, even if they have to adjust over time. And it's all about a scientific process at the end of the day, right? Know the boundaries of your experiment. When you get surprised, when your hypotheses don't work anymore, then go figure out what it was that changed. Was it the initial conditions? Was it the configuration of the experiment or whatever? And whatever it is, you'll learn something. Share that learning with everybody, all stakeholders, all customers. So, Martin, thanks for being on. In another couple of years, I want to come back and also talk with you face to face somewhere in the world, and then also we'll see what else you've written about. So, good luck. And by the way, you guys at ASML, you're the future repairers. You get that, right? We don't have enough chips in the world, and we're making them all in the wrong places. And so, please keep making machines so that, and at least U.S. and Europe-based IC manufacturing can pick up the slack. Okay. Thanks again.
Thank you.
Hey, thank you so much for joining us. And thanks to everybody who tuned in and listened. We want you to listen to this podcast every single week for more thoughts, ideas, and actionable information in and around product lifecycle management. The Digital Enterprise Society is the place for the exchange of ideas around digital manufacturing tools. Go check us out at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.